In this tutorial, I will explain the asset scene structure of Superpowers using the 2D platformer template as an example. Superpowers projects are structured like so. The actual thing that you run, your game or your level, is a scene. That scene contains actors, and those actors have assets associated with them. These assets are anything from sprites to tile maps to models to behaviors. So for this project, we're going to look at all of the assets that it has, and then we're going to look at the scene that applies all of those assets. And then, in the next video, we're going to look at this behavior. So let's go ahead and fire up Superpowers and create a project that uses the template. First, go ahead and hit the play button in the top left corner and get a feel for what this template actually does and what it provides. We're going to explore this project by traversing down the asset tree, skipping the scene for now. First, we have a tile set, which uses tiles from the prehistoric platformer asset pack, which can be acquired off the Superpowers website for free. Then we have the tile map, which applies the tiles from the tile set and arranges them into a level. Note that there are two layers, map and collision. This will be important later. Then we have the sprite. Sprites are images with a grid size associated with them to tell Superpowers where the frame boundaries are drawn. Then you specify a range of frames to create animations. This sprite has a bunch of animations already predefined for you, as well as the grid size. Let's take a look at the scene where everything comes together. The scene consists of three actors named camera, map, and player, respectively. The camera is positioned ahead on the z-axis of the other two actors, so it can see everything, while the player and map have a z of 0. The camera actor has one component, a camera component, which is why we see that box when we select it. This component is where we define all of the properties of the camera, namely that it's orthographic, meaning that it renders things flatly, which is what we want in a 2D game. The map has two components. The first is a tile map renderer, which tells the actor to display a given tile map wherever it happens to be. Already supplied is the tile map we saw earlier, which is why we see the tile map on the screen. It has another component, an arcade body 2D, which also wants a tile map assigned to it. Basically, this tells Superpowers to give the actor a collision box that is a certain shape, and to base that shape off of the tile map, which just so happens to be the tile map we're also displaying. Note that the layers field is set to 0, which refers to the collision layer we saw earlier when we were looking at the map. Last but not least, the player has three components. A sprite renderer, which is similar to the tile map renderer, only, as you might guess, it's designated for sprites rather than tile maps. And then we have a behavior component. The behavior component allows you to select a class that has been registered as a behavior, and also access any public fields for this particular instance. We'll explore what that means once we investigate the behavior. And then we have yet another arcade body 2D. However, this one is very different from the tile map, since it is of type box and not of type tile map. And since a box already has a predefined shape, we don't need a tile map to describe it. Instead, we just need two numbers to designate its height and its width. It's through these arcade body components that Superpowers knows to let these two objects collide. However, just attaching the components isn't enough. We'll have to employ the use of a script to outline how the objects should interact and react to each other. What we have told Superpowers with what we've explored so far is that we want two objects drawn on screen. One is a sprite, and one is a tile map. We also want these two objects rendered through this orthographic camera. And these two objects are going to have arcade body colliders. But in order to take this project any farther, we're going to need a script to allow these objects to interact and respond to user input, which is what we will cover in the next video. For those interested in TypeScript and its implementation in Superpowers, I delve into the script in the next video. For everyone else, that's pretty much the basics. Your project is just a bunch of assets, and some of which depend on each other, like tile maps and tile sets, and your actual game, as in the thing that you run, is a scene, which combines all of the assets that you have in the form of actors. There are a bunch of things that we didn't look at in this template, such as models and lights and other neat things in Superpowers. But this is meant to be a basic overview, and it is just that. If you're interested in acquiring Superpowers, as in the editor, not actual Superpowers, although those are not necessarily mutually exclusive, then you can find a link to their site below. It's free and open source.